All right, everyone, and welcome to class activity 9, which is just the first part of a two-part assignment that is just going to help you build with your second project. This is built off of your first project, which is a virtual pet simulator. However, in this case, you're going to be using a little bit of different mechanisms. So, for example, you're going to be having an outcome where you're going to have grids and moving your pet throughout that grid process and having user output so that the user can actually see the instructions and using some of the skills that you've accumulated over the last few weeks and adding it in here, along with introducing a little bit of functions, which is what we went through on Wednesday a little bit. So this is just going to be the walkthrough provided for this specific assignment. So what you would have done is to make sure that you download this starter file, which is labeled Class Activity 9 Virtual Pet Grid. When you open up that, you should see an assignment like this. Yours shouldn't have that one there. I can go ahead and remove that there. But it should say Class Activity 9 Virtual Pet Grid. In this section here, what we're going to be looking at is using global variables and a little bit of movement within our virtual grid using emojis. So the very first thing we're going to do is we're going to set up, make sure that we import the correct modules. So we're going to be using random to help us place the food, bed, and toys of that specific pet randomly. Um, And then we're also going to use time so that we can pretty much use it later on to add pauses or different animations for part two. So these are the modules that we'll be using. All right, so first things first, once we get past this section here, what we're really going to be looking at for this part is pet selection and naming of the pet. We're looking at the grid, basically the house map. We're also going to be looking at obstacle placement, where we place in the food, as well as the health status, and user information. And so I'm going to start with the file that we had on Wednesday, where I kind of showed you how to create a function, but also go through each of these steps. Okay, so now that we have the modules, let's start by actually defining these symbols here that will appear in the grid. And these are just going to be emojis that represent part of the pet world. And since emojis, when we create them, we are going to be using strings. So the first thing I'm going to be making is these global constants. So it's going to have to be all caps for these. So here it's going to be walls. We know that we're going to have floors, food bowl, beds, and toys. So for the first one, oh, and we need to also have a pet. Get to that shortly. So for the first one, which is walls, you can pick any emoji that you would like or any emoji that shows up on your platform. So you would just do for Windows, you'd pick the Windows key and period. And for this, so just type in wall. And this will show up as you can type in brick as well. And so we have this here, but you want to make sure that you put quotes around it here. So we have walls. We also need to have floors. I'm going to just copy this. Space in between. And food bowl. For this, it can be pretty much any food item that the pet is going to be eating. And then beds. And lastly, toys. Or Not lastly, we're gonna do toys there. And and I'm just going to make a list of my pet here. So I'm just gonna put the puppy here because eventually I will use this. We're gonna put a cat. Okay, and then a bunny. Okay. And I also want to make sure I put obstacles in here. That's not going to change. So I'm just going to probably put like a chair or something that an animal can run into. Okay. So we have our variables here, the walls, floor, food, bed, toys, pets. So we're kind of designing the world here. You can add in other items that you would like to show up within your grid. Just remember it's supposed to be a 7 by 7 grid. We do have walls and floors, food, bowl, beds, toys, and obstacles, as well as a list of our pets. What was given to you is obviously the colors here. However, it's completely up to you if you would like to modify it or change it as you program it and you go through that process. So now that we have our global variables, we have our obstacles, which is the most important, and this might be modified later on, depending on how we would like to code it or even the instructions later on. So now that we have defined our symbols with our constant variables, these are going to be different parts of that pet world. The next thing we're going to look at is moving into the pet status here. So these pet values, variables, are going to be tracking the well-being of your pet. And like what is mentioned inside of the activity here, we're really just going to be initializing hunger, happiness, and health to 5. And the scale here is the kind of range. So we have 0 being full, 10 being starving, 0 being sad, 10 being happy, 0 being sick, and 10 being perfect for health. And so for you, this would be the scale that we're actually going to be using. So in this first setup here, I'm just going to type in hunger and set that to 5, happiness and set that to 5, and health and set that to 5. Now these variables track the pet's well-being, and we know that it's going to be from 0 to 10. We know that hunger is how hungry the pet is, happiness is how much fun your pet is having, and health is overall well-being. So now that we have this section here, we've assigned those values and those variables and the pet stats here. We're going to move on to building our grid. So we're going to be looking at a 7 by 7 home grid, and this is going to be a 2D list. This is a list of a list. And each tile or cell is going to be the wall. This is going to be the outer part, and each floor is going to be the inner part. And for this, we would use our nested loop. Like I mentioned when we went over loops, it's really great for 2D matrix, grids, even iterating through this. And this is one of those examples. So this is where the loop is inside of a loop, where we're building the grid row by row, column by column in that way. So the first thing you're going to want to make sure you do is make sure you have your constant variable of the grid size being 7. Now this will be updated later on in the future, but for right now, we're just going to make it 7. And I will remove this. So first things first, I'm going to just do constant variable. grid underscore size, and we're going to set that to 7. And for this one, as I mentioned in class on Wednesday, I kind of introduced different functions. In the assignment here, we're just setting the grid size to be 7, which is perfectly fine. Later on, it talks about having a main function that will be used as like testing to run each other function here. So in this case here, we have the grid size. We set it to be 7. We could also create a function that we could call. So I could do, when we create a function, we're going to use the def keyword to define a function. And then in this case, I'm just going to call this get grid. So get grid size here. And I'm just using uppercase for each second word, but it would be best just to separate it like this. All right, so we have this function, and anytime you create a function, everything that you have inside of your function needs to be indented in. So you'll notice here that I have a tab in or tab over here. This is a space. This is how you create a function here. And so in this case here, I've defined the size to be 7. And if I wanted to call this just to test to make sure that it worked well, I can actually print out grid size just to make sure it works. And I will actually call, this is what we call a function call, this function. So we're going to do get grid underscore size. And the only difference that is a difference between a function call and actually defining a function is for a function call, we don't use the def keyword and we don't use the colon at the end here. So now when I run it, we know that the grid size is going to be 7. So we've set that grid size to be 7. Now we're going to move on to the other aspects of this activity. Later on, this will come in handy when we actually going to ask the user to input that information, and we can just return the value here. But until then, we're just going to move on to the next step. So we know that the grid size works. The next thing that we need to do is we need to now move on to the user input here. Let me see. After the grid size here, we're going to move on and we're going to create a main function. All right, so yeah, we're going to create a main function first. So in here, I'm just going to go down. Yeah, I'm just going to go down because I'll have to call these later. So add code here. And this is where I'm just going to add my main function. Should call, then we're going to do main here. All right, so inside of here, we're just going to do call other functions. And we're just going to have a simple print statement here for the time being. And I'm just going to say in main function. That way, when we do start adding in items, we know that this is working. So we've defined our main function here. And this is going to display the user instructions. It's going to prompt the pet selection and naming. It's going to generate grid and object. It's going to call all of these. So the first thing we want to do is we need to implement a function called user instruction here. So I'm going to copy this information, copy the header to make sure it's the same. And again, at the very top here, this is expressing what you'll be doing. It's kind of trying to explain to you what you do with the grid, but it's not actually requiring you to actually do it right here. All you have to do in this section is to set up the grid size. And as we get to these other items, we will go back up. So for this section here, I'm just going to go ahead at the very top here where the grid is, and I'm going to define a function called user information. And you could just put a number here, use the markdown, say user information if you are confused on how to section it off. You can make your own markdown and then just paste the name of the function here. And we're going to do define user instructions. This is going to be what the user sees. If we look at the visual representation of the output, we have a welcome message, we have how to play the game, we have how the stats work and show you warning signs. Pretty much the whole mechanism of the game structure we are wanting to let the user know so that they can understand how to play the game. So I'm going to pause the video real quick after I do the first line so I can add in all of the features that I would like. But the very first thing you would do in this user instruction function is you define it, and then you're going to print out some message here. So you first would print out, for example, welcome to virtual pet game, and you can make this as nice as you'd want, put some emojis in it. It's completely up to you. It's meant to be a little fun, something that you'll enjoy doing. This is one way to do a welcome message. I will actually show you once I pause this and add in more. Another way to do it that makes it a little bit easier, but it's completely up to you how you want to structure it. All right, so I have assigned to a variable called message, using the three open quotes so that I can have multiple lines of comment here that are being displayed. So I have my welcome to the virtual pet simulator, like you see in the image, and it says, hello, pet owner. Your mission is to take care of your pet. You must feed, play, and rest your pet to keep it happy and healthy. Be careful, avoid obstacles when moving around the house. Use W for up, A for left, S for down, D for right to keep keys to move your pet. If your pet finds food, it will eat it and reduce hunger. If your pet reaches the bed, it will rest and restore health. Playing with toys increases happiness. Warning, if hunger reaches 10, your pet's health will start to decrease. Keep your pet well fed and happy and rested to win the game. So this is all stored, if you notice, inside of this variable message, and then I just print out message, and this is one option to do. So if you prefer to just have everything all in one little section assigned to a variable and print it out once, that's also okay. But if you prefer to do line by line, you can do it just like that as well. Making sure that you put new lines where you would like each section to be separated, but either or works perfectly fine. Um, I tend to preference this option just because it makes things a lot easier. However, I do understand that some may prefer this. So for the time being, I'm just going to use this option here. And if you'll notice, if I run this, nothing will happen in terms of visually for you to see. However, once I call this function, And I'm going to call this in our main just to start off with. This is when it will actually run. It will run once I run this specific section here. So when I press play, I run this. What's the issue? First, I have to run this. Okay. Run this, and then now it should work. All right. So now here, when I run this, it has welcome to the virtual pet game. It has the visuals of what I want. It has the new lines where I want the new lines, and the instructions are clear for the user to be able to run this. So I'm actually going to get rid of this print statement now since we already have one. And I'm also going to get rid of that first line of my user instructions that I did as an example because we don't need it. Only keep exactly what you need. So now that we have the user instructions, we kind of have a good gameplay so far. The user can see it. And later on, we'll get into actually converting this information into an application that is more interactive. But for right now, this is the user instructions. So we're good with this one. The next thing that we need to look at is how we go about actually moving the pet and how to interact with the pet and that kind of information there. And allowing the pet selection and the naming of that pet. So the next step is going to be dealing with that. So what I'm going to actually do is call or copy this prompt user function here. And I'm going to go into our Google Colab. And I'm actually just going to put it right underneath it. So I'm going to define this function right underneath the user instructions. It's not inside, which you can do, but we haven't gotten to that yet. So as I've defined this function here, I know I'm going to just do a quick print message in prompt user function. And I'm just going to label this whatever number it is on here, number two. Number two, and this will be number one. All right, so for number two, what is required of us is to display the pet selection, and it wants us to accept input either one, two, or three to choose a pet. So just by this here, we probably a list would be okay to use. However, dictionary may be better to be associated with the number and the actual pet. So what I'm going to do is go back up to where we created that list of pets, and I'm going to convert that and change that into a dictionary and have one be associated with the dog, two be associated with the cat, and three be associated with the pet. So we have a key and value pair here. That way it'll be easier for the user to pick which one they would like and for us to convert that information. So because I'm wanting to follow the exact same format as the image, so you can confirm that it's done correctly in the way that if you're someone that prefers to follow it, this kind of thing to the T. Here, I'm just going to make sure I put welcome to the virtual pet simulator, choose your pet and display it out for them. And then I'll say enter one, two, or three, and then they would have to enter in some sort of input. So I know this is the section that I'm actually going to want to have. So in the prompt user, just going to get rid of this. And the first thing I'm going to do is do a little print statement, and I'm going to have quick little welcome message in here. Say welcome to the virtual. Gonna go ahead and put that mouse thing there as well. Okay. And then the next thing we're gonna do is print out, choose your pet. Again, this could be definitely assigned into one variable, but I'm doing this line by line, so that if you prefer to do it this way, you can. So here we're gonna just say print out, and we're gonna do one, and I'm gonna put dog B. I'm gonna do the same thing for cat and rabbit. Change this to two, change this to three. So now we have these three options here. It'd probably be cuter to say bunny. And then now what we're going to do here, because this is prompting to the user, but we need to be able to read in the user's information. And what better loop to use, since we don't necessarily know how many times they're going to pick, if they even pick the right thing or not. Um, we're going to be actually using a while loop here as opposed to a for loop. So there's going to have while true. Again, if you prefer to use a Boolean flag, you can. If you prefer to use a variable, you can. I'm just using while true because I can eventually use break later on. So here we're going to use choice equals input, and this is going to be the user's input. And again, like I keep mentioning, I know that Zybooks just uses input without prompting the user, but for reality purposes, you would like the user to know what they need to enter in. So you need to do enter 1, 2, or 3, and that will prompt the user to enter it in. Whatever they enter in will be returned as a string here to choice. And then the next thing, what we're going to do, and if you guys remember, now that we have these kind of items in a little bit of a section, we can actually use this in an if statement. So I'm going to actually show you. Some of you guys have already used this multiple times, but if the user's choice is in, and we're going to use that in operator there, and we're just going to place a list in here. If the user's choice is 1, comma, 2, comma, 3, so meaning if it's in this list, then what we're going to do is break. They're no longer allowed to pick anymore. We're going to break out of this. And we're going to print out some input here. Because just as we have an if statement, following that will be else. So if they didn't prick or press 1, 2, or 3, and it doesn't come out of this while loop, then we should print out a message to the user that they typed in an invalid choice. So here you're just going to do please enter 1, 2, or 3. All right. And so now that we have this while loop set up for the user input to kind of be able to choose one or the other, we want to test it out to make sure that it works. And one of the things that you would do here by testing it out is just call your prompt user function here, even though we know we're going to put it in the main. We're going to call it here just to make sure it works right. And again, one thing I did wrong was I need to make sure that that prompt user is underneath the defining function here. So here we see welcome to the pet simulator. We choose cat. Okay, that works. Let's choose some random value, invalid choice, or, and it keeps on going. It keeps on going until I click something from that list here. So we know that this works. The only modifications that I'd probably like to do is pretty decent. It's this space here. But other than that, everything else is good. So we know that this part works. We don't have to worry about the while loop not breaking out of what it should break out of. Now we want to move on to the next part of this, which is choosing the pet option. So like I said before, at the very, very top here, we created a list of pets. But instead, let's go ahead and convert this list into a dictionary here. So I'm actually going to, instead of using the square brackets, we're going to use the open close curly braces. And for the very first one here, I'm going to have string one be assigned to this string with the dog. String two be assigned to the string with the cat. And string three be assigned to the rabbits. And now we have a dictionary of pets. This means that it's consistent, these values of pets. If you want to add more, you can. So now that I have pets set up, the next thing I'm going to do in this same section, because I want to keep it the same, is make sure that it's underneath the while loop here. Okay. So I'm going to create some variable called pet symbol. This is going to be based off of the option that the user picked. So I'm just going to type in pets, open close square brackets, and based off of the choice that the user picked as the input, it will choose the pet from that list. And if you notice, before I entered in choice and you hover through it, maybe even, well, it did show up before, but basically what showed up was either you could enter in quotes of one or two or three. And in this case, choice does the same thing because it's going to return either one, two, or three. So once that is set there, I'm going to make sure that the user's choice is assigned to something called pet symbol. And this is going to be what we should be able to see. And then the very next thing I want the user, after they've picked their choice, we also want the user to pick the name of their pet. So we're just going to create a variable called pet name here. And then what we're going to say is just a prompt, what would you like your pet name to be? And what we're going to do with that user input is we're going to strip all the white spaces out. We're also going to make sure that we capitalize the name of the pet. That way we get it all properly formatted in the way that we would like. All right. And so in this section here, you notice that pet symbol and pet name in this function is not a global variable. This is a local variable. It's within the prompt user function. So is choice. Choice is local to this function prompt user. So in order for us to get access when we are even, for example, randomly generating where the pet objects will be when we're placing the pet information. In order for us to get the info, we would need to share in these other separate functions, we're going to do something called return. And again, this is just an intro to functions. If you have been coding this without functions, that's perfectly fine because this does not require it in detail except for the main. Um, so what you're going to do here is you're just going to do return. And what this return does is it's going to return whatever item you would like to return. If you want to return zero, it returns zero. If you want to return the choice that the user put in there, you would return choice. In this case, we want to return the pet symbol and the pet name. And we can do that, but just making sure that when we call this function, we are assigning to it a variable that we can see. So what I'm going to do here is to the left, I'm going to assign something called PS for pet symbol and PN for pet name. And I'm going to make sure that I also print that out as I'm testing it to make sure that everything is working correctly. So I'm going to use format and print. I'm going to say test pet symbol is open close curly braces. And then we have pet name is open close curly braces. And I'm just going to put in here P N and P. So I'm going to run this. And we see we keep typing in. We know that works. I'm going to go ahead and type in 3 for bunny. Hopefully that is what we see for the symbol and also the name of the pet once we enter it in. And let me go ahead and just run these top modules real quick. I cannot wait till we get into Visual Studio Code next week. Funny. Okay. And for the sake of the video, we're just going to type in Elsa. So we see here, yes, it got the right pet symbol and the right pet name when it was returned to the function call. And in this case, the values were returned to our variable after the function call. And what you'll notice here is even if I decide to, for example, put pet symbol here, it won't work because it's not within this function, the prompt user function. So you'll notice that even PS and PN are local variables to clearly not either of these two functions, but just this cell itself. So we're going to get into local and global variables a lot more now that we're getting into functions. So you'll kind of see the difference of it earlier on in the semester. For those of you who understood it, great. For those of you who are struggling a little bit to understand the purpose of it, here is where we'll see the purpose of it. So now that we know that this works well, we're going to take this line on line 40. We're going to copy it because the test works. And I'm going to actually uncomment or comment this out, the lines of code that I have, and I'm going to actually paste this in main. Right after the user instruction, I'm calling the prompt user and storing it into PN and PS. I'm just going to make a note here because sometimes we don't always remember. So this is going to be pet symbol and PN is just going to be pet name. Okay. So we have that one section done where we allow the user to pick their pet. We're allowing the user to keep on prompting, keep on entering in until they enter in the correct information. We have controlled the user's input in some way, and we've also used our constant global variable dictionary here to be able to assign the symbol from the dictionary that the user picked and also assign the pet name to these two variables and return it from this function. So we have something that is working. Now to make sure that everything is working hand in hand, we're going to run this main function too, just to check to see it works here. So I'm going to pick a cat instead of a bunny, and I'm going to name the cat Robin. And hopefully we see here, okay, so we got the cat when we got the name of the cat. So these all work well. So we know that we finished with this section. Now let's move on to the other aspect of this section. We have to move on now to the generating of the game grid. So we've already created a variable that is going to hold the size of the grid. But now we need to actually generate the game grid. It means we need to initialize the 2D list. We also need to fill the edges with walls and interior. So here is how we will do that. All right. So I like to keep things sectioned off in the same area that they were in. And since the grid size is right here, I'm going to go ahead and just add in the function in here. And I'm just going to make sure we put testing grid function. Right. So the next part of this is actually going to be creating that grid. So I'm going to define this function. I'm going to call this create grid. And inside of this, the first thing I want to do is create an empty list like we have here. Start at an empty 2D list. So right now we're just going to create grid. This is our empty list. The next aspect of this for us to actually use is to make sure that the grid goes to a certain size. So what mechanism, what loop, in fact, is best for looping through the grid size, making sure we go from 0 to 6 in terms of the grid size. We know the range of our grid. We know we want it to be 7 by 7. So we're going to use a for loop to make sure that we get each section placed onto our map here. So the first thing we're going to do is type in our for loop for row. And in this case, I'm just going to use row for rows to keep up with the grid so you can see it, but you can use I and J and all of that. So we have for row in range of, and inside of this range here, we're just going to do grid size. And we see here, yes, we have our grid size here, but this is actually meant to be a global variable. So I'm just gonna, because we were testing it out and I was showing you how to actually create a function, I'm just gonna get this out of a function so that it's a complete variable on its own. We don't need to do that. So here we have the grid size. Great. So it's gonna go from 0 to 6 here. Then inside of this, what we want to do is we need to now create another empty list, and this is going to be for the rows. So we're going to do row underscore data, which is just going to hold the row data. And this now, we need to have our for loop for the column. And this will make a little bit more sense once we get into it, but this is going to keep track of the rows, the outer loop, and now we're going to do the inner loop for a column in range of grid underscore size. And then inside of this section here, this is where we're going to use our if statement. Because if you notice in the image here, we have walls on all aspects over here. 1, 2, 3, 4, 5, 6, and 7. We have seven columns that head off with a wall and only 2 columns that have a full column full of walls and 2 rows that have a full row of walls. Everything else would have the floor in this case in it, and it won't even have these objects yet because we haven't placed it. So with that being said, I'm going to go ahead and go through the if statement, but I will also explain it with the grid so visual for visual learners. So here we have if the row is equivalent to 0, or the row is equivalent to the grid size minus 1, or the column is 0, or the column is equivalent, oops, it needs to be, is equivalent to grid size minus 1. Now, what this is essentially saying, let's stop with looking at it if this is confusing you. So again, when we're using a for loop, forget about this row data, forget about the grid list, just look at the two for loops here. The first for loop, if you helps you to look at it as I and J, please do so. With the first for loop here, it's saying if row is equivalent to 0 or row is equivalent to grid size minus 1. Now let's look at the image. This is row. This first row is equivalent to 0. So we know this whole row is going to be walls. The next row is grid size minus 1. And if you remember with range, it only goes up to 6. With the for loop, it doesn't go up to 7. So with that grid size minus 1, what it's saying is 7 minus 1, which is 6. So if row is equivalent to 0, or if row is equivalent to 6, then this is where your grid will be. So these two will be something that you're working with. Then the next one is if column is 0, which is this line here, which is true here, or if column is grid size minus 1, which is over here, then we know that in this case, it will be column is 6 and column is 0. So these will give us the parameter of our wall. And that's what that if statement is essentially doing, is it's giving you checking to make sure that that parameter is there before we assign wall to it. So the next part of this that we want to do, because the row data is empty, we need to store the wall data inside of the row data part of the list. So we're just going to type in row underscore data. And how we add to a list here is using the append function. And because we already have that global variable at the very top called walls, we're going to go ahead and place walls in the append section. Just so. Right? And then other than this, if it's not on the perimeter of that grid, we're going to have our else statement here. We want to append to the row data the floors. And now that we have these two here, what we next want to do is not under the if statement here, but under the for loop here, we're going to place in the grid, which is that empty list at the top, and we're going to append to that now. Now this is where we get our list within a list, because we have that empty list and then we have the inner list for each row. That's what it will look like. So what I will do is append row underscore data. And then what I'm going to do from this function, because we will, pardon me, we will have to reuse this grid over again. We're just going to underline underneath the very last for loop, still being inside of this function, create grid. We're going to return grid. Again, this is only if you're using functions. All right, so what we're going to do here, just to test it out to make sure everything looks decent, gonna call this function here. And since it's going to return a grid, I'm just going to print out. We're gonna run this. All right, so we see it is a list within a list. We have our first row here, all wall. The second row has wall and then floor, then wall. The last row should have all floors or all walls, and it does. So we see at least that the structure of this list within a list worked well. So the testing out of it worked well. We see that it worked. So the next thing we have to do, since we've generated or created this list or this grid now, and we've filled the edges with the walls and the interior with the tiles, now we need to generate these random positions. And so we're going to create a function called generate positions. And for that, I'm just going to add text here. Again, I like to keep everything together. And if you'll notice, some parts of these were not necessarily added because you have to get used to actually using some of this before we switch over to Visual Studio Code, like I mentioned in class. So here, when we define this generate position function here, and pause real quick before we move on to that, I'm going to just copy this function header, and I'm going to comment out this testing. And I'm actually just going to go into main and call this function just to make sure I have it. I may need to modify it since it does return the grid, but I'm at least calling it here in case I need it for later. And since it returns a grid, I'm just going to store whatever is returned into this variable grid. Okay, so now that we've done that, we know we're going to move back up to generate positions. So with the generate position, we know that we need to be able to store all the valid positions inside the house, excluding the wall, and shuffle the positions to make sure that the randomness is involved. So we're going to use our random, and we're also going to use the built-in function called shuffle. So before yeah, we can do that. Yep. All right, so we're going to go ahead and do that first. But before we do, we're going to go ahead and display this original data in the proper way at the bottom. So I'm going to just do a quick print of generate positions, and we're going to just do that here. So we have the main. And I'm just going to create a function here called display. So just so we can see it. Okay. Let's display grid. All right, so for this section here, what we know that this is going to need to take in is because we don't have the grid right now. The grid is actually all the way up here and it's returned from this function. So I know that we're going to need to take in the grid here. So in this case, I'm going to make, since this function is requiring the grid, I'm going to create that variable grid right here so that that value gets passed in and stored into this variable called grid. And I know that in this function, I'm going to be using grid. So I'm going to say for every row in our grid, our list here, and for every cell inside of that grid, we're just going to print out that cell and we're going to left align it. So we're going to use left just by 2 spaces. You don't have to use this. You could even use join. But here in this case, what you are going to use is end, and we've used this before in past activities. And that end is actually going to create a space in between each square to allow for you to get this kind of grid pattern here. So it would be the cell, then the space, cell, then the space, cell, then the space. And so left aligned 2 spaces. Right. And then I'm just going to have a print statement here just to allow for that empty space, and then another print statement for that next function here. So here, what I will do is copy this function header here. And this is going to print each row neatly and nicely for a more visual environment. And I'm going to actually paste it right underneath here. So it worked out in our favor. We're going to be using grid, and I'm going to run this to make sure things worked well. So first things first, we know our prompt works. We know picking the animal works, so that's not an issue. And let's see if there are any errors or issues. And so yet we do. Display grid is not defined. And that issue is because I didn't run it. Well, we're going to go up to the display grid, which is right before main. And we're going to run it. Now we're going to run this main. So 3, Robin, um, list object is not. Hmm. Let me take a look to see. It's a good thing we catch those things. So we have the display of a grid here. For some Okay, what about in the creating of it? Into grid. Mm. Ah, I see. Display grid. We call display grid. 4 row and grid. Oh, okay. On line 3 in the display grid, we need to remove grid and put row instead. Instead, this row portion here, beforehand it was just reading grid within grid. Now it should work perfectly fine. Let me go ahead and run this again. Okay, awesome. So here is the grid. We have our left line and then space by each two, and we have our outer being the wall and our inner being the floor. So we know now that everything works. What we had to correct was this line to make sure it had four cell in row and not four cell in grid, which is what I had earlier. All right. So now that we have that, now we can move on to the object placement here, where we talk about generating the positions. Now, for generating the positions, we are going to be using random for that, and we're going to be using shuffle for that information as well. So first things first, let's get into it. Gonna do a generate positions. So this is where we're gonna list all of the possible coordinates that these objects can be placed. And we're going to randomize it. So I'm just going to create some variable list here, an empty list called positions. Then I'm going to say for every row in a range of, and because we have a constant grid size here, where we see the grid size is 7, we can actually use that here, and it's not within a function. So we're going to say for every row in range of 1, we want to start with 1, not 0, because 0 is going to be for the wall. 0 is this line here, so we want to start with 1. So we're saying for every row in range of 1 to grid size -1, and you'll notice that's available to us. And we're going to do -1 here to make sure that we get the 6. So now it's going to go from 1 to 5 and not 1 to 6. Because this grid size -1 is 7 minus 1, which is 6. So it's going from 1 to 6 now, which means with range, it goes from 1 to 5. It's going to be everything within here. So it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Everything that's in here. All right, so now that we have our for loop that's going to iterate through a specific range of values, we also need to have the column for it as well to do the same. So we're going to do for column in range of 1, grade underscore size -1. Then the next thing we're going to actually do is we need to append these positions or these coordinates rather into our list called positions so that we at least have a list full of positions that we can use. So we're going to use positions dot append, and we're going to append to this, and I'm going to make this into a tuple. So we're going to have row, comma, column. So we're appending tuples inside of this list of coordinates here using the grid information that we have. And it's not going to be the 7 by 7, but it's going to be the 6, 1 to 6, or 1 to 5 in our case. Then now, because this is all in our nested for loop, it's just going to append the right coordinates. We need to now, under the first for loop, use our random module. And we want to access the shuffle function here. And what we're going to do is put in positions, the list positions. So we're going to shuffle the coordinates that we place in here. So prior to that, we created an empty list of positions. We have a nested for loop now to go through the range of this said grid from this item here all the way inside of this grid. And we're adding those tuples of those positions into the list and then shuffling it here on line 7. And now what we can do, since this isn't a function, we're going to actually return positions. So we're going to return the positions, but right here, what this does is it just shuffles it. So now that we have this said function to generate random positions, I'm just going to copy this. So first, let's test it. It returns positions. Just going to print out positions. Okay, so we're going to run this. This needs to be not indented in so that it actually works. All right. And so here we see we have a range of coordinates tuples here from 1 to 5. We don't see any sixes in here. So we can actually pick some random value here. We have 5 and 1. So 5 and 1 would be 1, 2, 3, 4, 5. 5 and 1, so it would be right here. Interestingly enough, right here. So this would be 5 and 1. So we know that the position shuffled work. Let's run it again to see. And we see it shuffled again. So we know that it changes and it works right. So our testing of this function is done. And we're just going to take this line and place it inside of the main function below. See how you're building your program slowly but surely, everything will fit together. So now that we have those positions, the very next thing we need to do is we want to place the objects. We're going to try to place these objects inside of the grid. And this is the thing that may take a little bit more time here. We've already done the display grid function earlier when we were testing it out, so we don't have to worry about that. But we do need to worry about placing the objects. So I'm going to copy that header here, or that function header. And in this, we're going to start by having a starting position for the pet. We're going to have a starting position for the food, the bed, the toys, and the obstacles at random positions. And we're just going to update the grid with these specific objects. Now, if you take this one step at a time, you will actually understand how to do it properly. Um, but again, you have to take your time with it. So in this section here, I'm just going to add in another portion. And I'm going to have the text here, and this is just going to be called place objects. And I'm going to just paste this header here. And because this is a function, we know that we're going to need to we're going to need to define it first. We define the function. This is going to take in the grid positions as well as the pet symbol. So we know that it's going to have the grid from the main, the positions that we just generated up here, as well as just the symbol of the pet, which is where we returned here just the symbol or the image, which is just this pet thing. So that is all going to get passed into this function. Now, for the very first step that it asks us to do is we need to assign the starting position of the pet. So the very first thing we'll do, we're going to create some global variables here. And in this will help us update these anywhere we would like to actually use the global position of of that said pet. So in this case here, I'm just gonna do global, oops, pet position, and then food position. Okay. And in this section here, what we're gonna do is we first need to use our pop function to get the very next item from this list or getting the position there. So I'm gonna do pet underscore position, and I'm gonna assign to that from the positions list that we have, what we pass in here. And we're going to use dot pop to pop the very first item here. And in this case, it'd be 3, comma 2 if it uses the same functionality, but it will call it again, so we will see. And then we're going to do the exact same thing for the initial position. So I'm going to just make sign initial position. And we have our pet position. Now we're going to go ahead and add our food position. Is position dot pop, and we're going to do the next one, which is still going to be 0 because popping pops the very top part of that list. And we're going to do the same thing for bed position. And then we're going to do the same thing for toy position. Okay. So now we have our initial positions. The next thing we want to do is just add in obstacles. So we want to add in 3 random obstacles. And by doing this, we know that we're going to need to create a list. And I just call this obstacle position. And this is going to be an empty list to start off with. And then afterwards, what we want to do, since we know that we want 3 items here, what loop do you think we would want to use? If you said for loop, you were right. So we're going to be using for I in range of 3. Remember, range by default has 0, so it's going to go from 0 to 2, still having those 3 items. Right, so here we're going to do obstacle positions, and we're going to actually do dot append. And inside of the append, we're going to repeat the same process. So we're going to do positions dot pop. And we're going to pop off that first item. And the benefit of this is because it's in a for loop, it's going to do this 3 times. So we will have added to our obstacle, our empty list here, 3 different positions that have been popped off of our positions list that has been passed in as a parameter and will be assigned to this variable positions for this local variable here. Then the next thing we're going to do is we're actually just going to update the grid. So when we move place the objects on there, we need to be able to showcase that with object placement. All right. So for this part here, we know we have to use the grid because this is what controls the items within that grid. So we're just going to go ahead and do grid. And since grid is a 2D list, in order for us to update it, we know we're going to have a specific position assigning it and assigning a specific item. So we know we want to do, I'm just going to go ahead and do this food bowl. And this is a great way to start. If you don't know what you want to put in for the open close square brackets, but you do know you need to assign a food bowl to it, then go ahead and do what you know how to do. And then you'll fill in the gaps later. So here, the next thing we have is we want to just include the bed. So that's another item we need to include. And then I also know that I need to include toys. And then lastly, I also know I need to include a grid. And that grid is more than likely going to be in a for loop because we have to iterate through it to print it out. So I'm just going to add in here just a statement, you know, for loop, and then in here, grid, open, close, equals. We're going to put the obstacles. And then I'm also going to include in here for the pet. So we need to actually know where the pet is. So, and this one is going to have the pet symbol. So now we know that these will quote unquote update with the correct global variables we had and also the symbol, pet symbol that was passed in here based off of the user input. But we first want to know what are we what are we looking at here? So for the food bowl, what we want to place inside of here, and if you guys pay attention to the tuples here, when we look at the food bowl, what's happening is this popping this specific tuple into your food position here. And since this tuple has both 0 and 1 position, X and Y, we know that for this grid, we will have a 0 and we will also have a 1 because tuples come in twos in this case. In this case. So the first thing we're going to do is have our food position variable, open close square brackets to access the first item, which is the X in that tuple. And we're going to do the exact same thing for Y. The only difference is we're going to change 0 to be 1. And that line is finished. And we're going to do the exact same thing for the other modules. The only difference is we're going to use the variables that we have. So for adding in beds, we're going to use bed position. For adding in toys, we're going to use toy position. Yeah. All right, and now for the obstacles. Hey, we can actually just use the same for loop, similar structure that we used up here. The only difference is we no longer need in range of. We know that it's going to be in range of this list. So we can actually use the for loop and we can say for obstacle in, and let's look, obstacles position, which is the list here. I'll put a colon in there. And then now you'll see that this throws a little bit of an issue error, not just because of the open close square brackets, but because it's not indented into this for loop. So now we're going to tab it over using the tab keyboard or the tab on your keyboard. And then here we're going to have obstacle positions. And we're gonna have, or I'm sorry, not obstacle positions, obstacle. This is keeping track of each tuple within your list here. So I'm gonna say for every obstacle here, and we're gonna make sure the first one is 0 and the second one is 1. All right. So that is it for that section, but we also need to make sure that we lastly have our pet position, where our pet is at. So what we're gonna do there is the same process. We're gonna have our X and our Y here for that. And we're going to assign at that specific location the symbol that gets passed in. Okay, and so that is it for placement of the objects and the pets randomly in our grid here. And we're gonna actually call this function in the main so we can actually test it as opposed to rerunning this multiple times. And we will see if there are any errors or issues throughout this that we need to fix. So now what I'm going to do is go all the way down to main. I want to print this out, but you'll notice, hey, we don't have a variable in main called pet symbol, but we do have something called PS. And with that being said, we're going to go ahead and pass in PS as pet symbol. And regardless of if we use this variable inside of here as a local variable, when we call this function, the value that we have inside of this variable is just going to pass hands. So it's going to go from PS to pet symbol in this function. From here on out, in this function, in this local function, every value that's associated to our PS and main is going to be associated to the pet symbol in here until this function is terminated. And that is that local variable is local to that function. Okay, so let me go ahead and print this out, and then I want to actually display the grid after, just to make sure it works. Okay, so I'm gonna go ahead and run that function since it seems like I need to do that all the time anyways. We'll run that function and then we will go and run our main. So at this time, Yelena. And we see our grid here. And then we also see, and this is where you'll want to kind of decide if you want to put an extra space for some of these to allow for more balance in the output here. But we see here that we randomly placed our pet somewhere. We randomly placed the 3 different obstacles that the pet could run in, randomly placed the food as well as the bed and the toy there. But you can make modifications to kind of make it line up right. And some people find that at least having spaces in between these, like having a space here, maybe having a space here and here really make a difference. I don't know. It depends on everybody how they would like to do that. For me, I wait until I'm kind of sometimes done before I move on to that. Okay, so now that we have gone through that first part here, we're gonna move on to 7, displaying the grid. So we've done that. The next thing we're gonna actually do, because this does not have anything to do with the movement yet, we're actually gonna be doing the movement on Tuesday when you actually convert it. Um, but here we're just going to display the pet status and the symbol name. that function here. Display stats. All right. So now we need to define this function. All right. And so with this one, this is pretty much very similar to kind of what you've already done at the very top beforehand, or what you've done before in the past. But we are going to need to do two things in here. The first thing, and I'm going to just do a simple print message here for pets stat and forward slash enemy. And then we're going to do another section here where we're just going to call get health color. And this specific function is going to take in the health that we have at the very top here. So for this section here, inside of the get health color, we're just going to use that if statement. If you guys remember here when I talked about the scale here from 0 to 10, you can pretty much play around with this. It's completely up to you how you structure the if statement here because you've already gotten the range. You already know what will make a mess and what wouldn't. This is where you have a bit of free range. If there are no instructions on how to do it, then you use your own thought process of how to do it. So in this case, especially since you have the knowledge for it now, if health is greater than or equal to 8, and I'll use 8 instead of 10, then we know that we're going to return green. Elif, let's say between 6 is less than or equal to health. This is a little bit gray area, and at least it's less than 8. We'll say that we want this specific function to return yellow. Warning. And this goes very well with the instructions that you created. So if you don't know how to do this or don't know what to do here, use your instructions that you wrote in terms of like the color here. So in this section here, I'm just going to say else, we're going to return red. So we have this kind of idea of what we want to pass in and the conditions of which we would either get green, yellow, or red. So what we're going to do here is we're going to call this function within our display stats at the very beginning. And we know that it's going to return some color here. So in this case here, we're just going to put elf color. And on this line here, this is where I'm going to start with the print information to the user. And I'm going to use formatting print. So here I'm going to say pet name. That's what's passed in as a parameter. And then inside of this, I'm going to have the pet symbol. It's also passed as a parameter and putting in open close parentheses for that. Status. And then what I'm going to do here, pause this real quick.
All right, so we now have this function call to the get color health here, and we are now printing out the pet symbol and the status of that pet backslash n. And then now in this section, we've already hard coded, and this part of the information we will work on for part two for the game mechanism part of it, where the hunger, the happiness, and the health will get updated. But until then, we're just going to display it here since this is part one. Okay. So we're gonna first have here, I put some emoji here, circle, and I'm gonna put red for this circle. And for this here, we're gonna just say hunger, quote, and because it's 5, we know that it's going to be red. But this we're going to obviously modify later on. Because obviously this only focuses on health. We're going to be adding in happiness and hunger as their own separate function to return the colors as well. But for right now, hard coding it in, we have red, and then we also have hunger, which is a variable that we had at the very, very top where we assigned 5 to. And we're going to say out of 10. And then at the very end here, we want to make sure that we reset so that the color is no longer red. We're going to print this out again. We have F, and I believe this one is going to be yellow. Do they have a yellow circle? Okay. All right. And here we're just going to have happiness, and we're going to say yellow, uppercase. And then we're going to have happiness as the variable. And then we're going to say out of 10. And then we're going to reset the color. And the very last one we're going to do, I'll give it blue. Actually, I like orange. It's a nice color. Should do that. Orange here, and then what we're going to have attached here is going to be the health color, the one that we returned back from the user. So here we're just going to say health, and then we're going to have our open close curly braces and type in health underscore color, because that's the variable we're using. And then we're going to put in here health, and then we're going to put out of 10. And then we're also going to make sure we do reset here. Okay, and I'm going to make sure I do a backslash n at the end. So the difference between this last line and the first two is this last line, we're using the health color from that function, get health color, and we're passing in some value of health in here. And in this case, we know that it's 5 at the very top. And that will get assigned here to whatever color we've dictated in our get health color. So, obviously we're going to be adding in at some point get happiness. Not right now, but get hungry functions in there. But for right now, this is just an example of what we would want to output. So I'm going to copy this function header here, and I'm going to go down and paste it inside of this main here. And again, we know that we don't have pet name, we have pet symbol, and we have pet PN. So that is what's going to kind of be displayed out afterwards. Now, these are the instructions for this first part of the assignment. You're just going to be doing this process here. We have not yet gotten to the movement of your pet around yet, and we haven't even gotten to properly displaying the right information for health, hunger, and happiness, but I did just show you a part of it. We have done step 6, we have done step 5, and in fact, I will go ahead and copy those steps into the right process here. So we have the grid. Let me go ahead and copy this down below. Uh, Here we go. Paste this here. We got that, and I will delete that. And I will also delete this one and delete this and also make sure this goes at the very bottom. Again, I like to do everything in one location before I section it off sometimes, especially with something like this. However, it's completely up to you how you do it. So here I'm going to just do enter, paste. No, that works. And we also did this part already. So and I do have, let's see, user information, display stats. We'll delete this. Okay, and here is the display stats. So I will also just copy this um, into the section for that. Again, here we will make some modifications to this on Tuesday. This was not fully, this is only just part 1. Yeah, so the splash of color would just be adding in this information. This below is pretty much what we will do for part 2. As well as, let me just delete this. Delete. Oh no. Okay, well, we'll just use this then. User information. Yep. All right. So, so this is just the first part. Again, step 7 and step 8 are what we're doing on Tuesday. I have already placed this inside of this document for those of you who want to try your hand at it. Let me go ahead and just put part 2 for that so people don't freak out too much. Part 2 example. All right. So hopefully now that you know, this is kind of what we're looking for the display status, and the get health color, etc. However, it is not it's not a requirement to do anything else except for everything that was in the class activity on Canvas. So everything up to this point is what you're doing. So I'm going to go ahead, run that, run all of this again, make sure that this is updated. Okay, and did this run? Okay. All right, let's run this main and test things out, see what's up with it. So we're going to do our dog, Elsa. And we have the instructions, we have the choice, we have the grid, we have the placement of the items in the grid, and I'm still not a fan of this. So I might adjust this a little bit to make the spacing of this not be that way. And then we also have our pet stat at the bottom. That looks perfectly good. So this is all that was required for this specific activity. Again, we're going to go in and do step 8 and step 7 in more detail, as well as converting it into an application on Tuesday. But this is all that this activity was requiring you to do. For those of you who want to try your hand at this, move your pet around, think about actually using a while loop and prompting the user to enter in one of those items. If they press Q to quit, then you break out of it. If they press any of those items, you update the grid. So think about that process over the weekend and even on Monday, and we'll go through this next part on Tuesday. Have a good rest of your day. Take care. And this is all, so you can submit this assignment.